Good afternoon to all. Last class we have seen only definitions of types of relations. From this class we will see what are the problems based on these types of relations. That is exercise 1.1 we will start today. Within 10 minutes I will upload my video. In that 10 minutes how much problem we can cover, as much as possible we will cover it. We will go to the video. We will see exercise 1.1 first problem today. So what is the problem given means the given relation is symmetric, reflexive, transitive or not, we have to check. So the given set is 1 comma 2 comma 3 etc 14 and 15. The given relation is x ordered pair x comma y such that the ordered pairs how they are relating means 3x minus y equal to 0. So we have to find first what are the ordered pairs will satisfy this equation. So we will write the ordered pairs. How to write the ordered pairs? We have to find the value of x and y will satisfy this equation. So the given equation is 3x minus y equal to 0, that is 3x equal to y. So what are the values will satisfy the given equation? If I am taking x equal to 1 means what is the value of y? Y equal to 3. So 1 comma 3. Next, if I am taking x equal to 2 means x equal to 2 means y value equal to 6. 2 comma 6. Next, I am taking x equal to 3 means y value must be 9. So 3 comma 9. You know how to get the values because x equal to y divided by 3 or y equal to 3x, whatever which one you want we can take it. In these two equations we can substitute the values means that should satisfy. So similarly if I am taking 4 means 4 comma 12 will come. If I am taking 5 means 5 comma 15. Suppose I am taking 6 means what will happen? 6 comma 18 should come, but this 18 is not in the set, given set. So this pair is not applicable, this pair is not in the relation. So these are the my elements here. Clear? So I found my relation set. Now I am going to check whether this relation is reflexive, symmetric and transitive or not. So how to check that? As the definition of reflexive, what is the definition of reflexive? A comma A belongs to R. A comma A belongs to R for all A belongs to the set A. This is the definition of reflexive. Clear? So now we will check that a comma a means if I am taking 1 comma 1, I can clearly say that 1 comma 1 does not belongs to the relation. Only one example is enough to prove that it is not reflexive. So 1 comma 1 does not belongs to R. So I can say that R is not reflexive. R is not reflexive. Suppose I can give another example. 2 comma 2 also does not belongs to R. 3 comma 3 does not belongs to R. Like that, how many examples we can give? As much as possible we can give, but only one example is enough to prove that it is not reflexive. So reflexivity over. Second, we will check symmetric. In the this relation is symmetric or not. What is the definition of symmetric now? Definition of symmetric is what? A comma B belongs to R. If the A comma B belongs to the relation, this implies B comma A also belongs to R. If A comma B belongs to R, this implies B comma A belongs to R, where A and B should belongs to the set. If I am taking, for example, first element I can take first ordered pair 1 comma 3 belongs to R. 1 comma 3 belongs to R. Here 1 comma 3 belongs to R, but what about that 3 comma 1? 3 comma 1 is not in the set. So 3 comma 1 does not belongs to R. As I said earlier, only one example is enough to prove that it is not symmetric. So 1 comma 3 belongs to R, but 3 comma 1 does not belongs to R. So R is not symmetric. The relation is not symmetric. Similarly, I can give one more example. 2 comma 6 belongs to R, but 6 comma 1 does not belongs to R. Another example also we can give. 3 comma 9 belongs to R, but 9 comma 3 does not belongs to R. Like that we can give many examples. No problem. Clear? So next, reflexive over, symmetric over. Next, transitivity we have to check. So what is the transitivity property? If A comma B belongs to R and B comma C belongs to R, this implies that A comma C belongs to R. If these two ordered pairs in the relation, this relation also should be in this ordered pair also should be in the relation. If this ordered pair is not in the relation, we can say that this relation is not transitive. If it is transitive, means A comma B must be in the relation, B comma C must be in the relation, A comma C also must be in the relation. If it is not transitive, means these two must be in the relation, this A comma C does not belongs to R, I need to prove. Then only it is not transitive. Clear? So now we will check that 1 comma 3 available in the relation, 3 comma 9 is available in the relation, but 1 comma 9 it is not in the relation. That is, I am going to write here now. Here 1 comma 3 belongs to R and 3 comma 9 belongs to R, but 1 comma 9, that is A comma B belongs to R, B comma C belongs to R, A comma C, that is 1 comma 9 does not belongs to R. So we can say that R is not transitive. So R is not reflexive, R is not symmetric, R is not transitive. Clear? Next problem. R equal to ordered pair x comma y such that the relation between x and y is y equal to x plus 5 and the value of x must be less than 4. So we will try to find what are the elements will satisfy this equation, that is what are the ordered pairs. First I am taking if x equal to what is given equation, x equal to y minus 5, or I can take y equal to x plus 1. If I am substituting x equal to 1, what is the value of y? If x equal to 1 means y equal to 6, so 1 comma 6. Next, if I am taking x equal to 2 means y equal to 5 plus 2, 7. Next, I am taking x equal to 3 means y equal to 5 plus 3, 8. I should not take x value is equal to 4 and greater than 4. X must be less than 4. And if I am taken one, I have taken only 1, 2, 3. I didn't take the negative values because our already given set of a value equal to 1, 2, 3, etc. 15. So 1, 2, 3, only these three values will satisfy for x. For that corresponding x values we got the y values. So this is my relation. Now I am going to check this relation is reflexive, symmetric and transitive. First, what is the definition of reflexive? A comma A belongs to R, such that is 1 comma 1 belongs to R. Check whether 1 comma 1 belongs to the relation. No. So we can say that directly 1 comma 1 does not belongs to R. So R is not reflexive. R is not reflexive. Next, we will check that the symmetric. So symmetry means, what is the definition? A comma B belongs to R implies B comma A also belongs to R. If I am taking the first element 1 comma 6, here 1 comma 6 belongs to R, but 6 comma 1 does not belongs to R. So I can say clearly R is not symmetric. R is not symmetric. Now we have come to the very important place. What does that means? We are going to prove the transitivity. What is the definition of transitivity? A comma B belongs to R, and B comma C belongs to R, which implies A comma C belongs to R, which is not transitive. This 2 must be in the set and this should not imply A comma C. That is, A comma C does not belongs to R means we can say that transitive. One more we can say that not transitive. One more definition we have seen. What does that means? If I am unable to find this second element, if I can find only one element A comma B alone in the set, unable to find the element starting with B, that is ordered pair as first element as B, I am unable to find means I can say that that set, that relation is transitive. Clear? That is the example problem for this. This problem is under that third category. So see that 1 comma 6 belongs to relation, but there is no element starting with 6. So this element is transitive. 2 comma 7 in the relation, but there is no ordered pair starting with 7. So this element is transitive. Similarly, 3 comma 8 belongs to R. There is no ordered pair starting with 8. So I can say that this element also transitive. So the whole relation is a transitive relation. How to write that, sir? How to write means we have to write that R is transitive. R is transitive because the definition of transitivity is not contradicted. What is that, sir? Definition of contradictivity? Why it is not contradicted means it should contradicted means this must be belongs to in the relation. A comma B must be in the relation. B comma C must be in the relation. This A comma C does not in the relation. If this definition true means we can say that not transitive, but I am unable to prove that it is not transitive. So I can say that it is transitive. Clear? Thank you.